Okay, topic number 1. Also, I forgot to mention in the intro, you can find all these questions on my Google Drive. Okay, prime factors. Let's get into it. So we need to split these numbers up. So 200 is 102. It is 4 and 25. Don't know why I did that, but why not? That's 2 and 2, and that's 5 and 5. Okay, we circle the prime numbers. 420 is 42 and 10, which is 6 and 7, which is 3 and 2. And 10 is 2 and 5. Fantastic. So let's draw a big Venn diagram, and let's see what's going to go in the middle. Well, they've both got a 2 here, so that can go in the middle. They both have another 2, so we can say that's 2 squared. And they have a 5 that they share, so that can go in the middle. And that's it, that's all they share. So because we're just trying to find the HCF, that's all I need to do, really, because it's the middles times together gives us the HCF. So it's this, which is 4 times 5, which is 20. Okay, great. Find the lowest common multiple of A, B, and C. Write your answer as a product of prime factors. Okay, so in order for us to find the lowest common multiple must have the highest power of any of the prime factors that are shared between any of the numbers. So for example, we've got a 2 here, so we must take the highest 2, which is 2 cubed, because, well, this number that we're creating must be a multiple of A, so it must have 3 2's in it. Let's look at the 3's. Use a different colour for that. Let's look at the 3's. Now, what's the highest 3 there is there? It's 3 squared, so we have to have 3 squared in it. And we have to have 5 squared as well, because the C has a 5 squared. And we have to have let's look at the the 7's. We have to have 7 squared as well. And finally, we have to have an 11, because it has to be a multiple of C. And there we have it. That is our lowest common multiple. Topic number 2, fractions. This is a classic type fraction, and what I recommend you do is don't look at that, shield that from your eyes, and just solve the question and hope that you get the right answer. So let's convert it into a top-heavy fraction. 3 times 7 is 21, and then plus the 5 makes 26. So that's how many sevenths 3 and 5/7 make. By the same logic, we do 8 times 1, and then we plus on 5. That gives you 13, and that's how many eighths we have there. Next step is to flip the second fraction and turn it into a times. That's how we divide fractions. And here I can spot that there is a factor of 13 on the top. And when I divide through by 13, I get 2, and there is one on the bottom. And when I divide through, I get 1. So now timesing top and top gives me 2 times 8, which is 16, and bottom gives me 7 times 1 is 7. And as a mixed number, how many 7's go into 16? 2, with remainder 2. So it's 2 and 2/7. Let's check to see if we got it right. Yes, we did. Bosh. Question number 3. Some members of a library were asked to name the type of book that they liked to read the best. Yada, 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 yada. We've got a probability table. 48 members answered comedy books. Okay, so this is 48. work out the number of members who answered mystery books. Okay, first things first, let's work out what X is. Because what we know about probability tables is they must add up to 1. Because essentially, they have to pick one of these books, I suspect. So therefore, there is guaranteed that it's going to be at least one of these, so they add up to 1. So what does this give us? Well, this gives us 4x plus 0.64, and we're saying that must equal 1. So 4x equals 1 minus 0.64. So 4x equals 0.36, and then dividing through by 4, we get 0.09. Okay, great. We are looking for mystery books, which is 3x. So let's times x by 3, which gives us 0.27. Okay. Now we need to figure out how many people there are in total. So from this information here, we know that 0.24 of the total number of people is equal to 48. Because, well, 0.24 is the probability that you pick comedy, so therefore there must be 0.24 times the total number of people. That will equal how many people studied or liked comedy. Okay, so the total number of people we can get by doing 48 divided by 0.24. That's 200. So 200 people took this survey. And now, going over to this part, the mystery book, well, if I do 0.27, that's the probability that people like mystery. So times it by the total number of people that took the survey, we should get the number of people who liked mystery books. And this is going to give us a 54. Bosh. Okay, topic number 4, the nth term. This is finding the nth term. So what we do is we look at the gap between them. And in this case, it is minus 7. We're taking away 7 each time. So this is very much like the minus 7 times table, which we write minus 7n. But it's been shifted slightly, because the minus 7 times table starts minus 7, then minus 14, then minus 21, then minus 28. Okay, so what have I had to add on to the minus 7 times table to get this starting value of 38? Well, I've had to add on 45. So my nth term is minus 7n plus 45. Now, as a little shortcut, you can always figure out what needs to be added on by imagining that there was a term before the first term. So going backwards along, this number would be 45. And there it is, 45. Let's go. Oh no, it's number 5, it's constructions, and it is the hardest topic to do online. Because I need a compass, which I don't have. What I would do if I did have a compass is I'd put my needle point right here, and then I'd make sure my pencil was at least halfway along. And then I would draw an arc like that and like that. Get it? I think that's quite good. Okay, then what do? We pick up the compass and we make sure we don't change the gap between the pencil and the needle, and we put the needle at this end, and therefore we then do the same thing from that side, and we get these two beautiful arcs, one coming from A, one coming from B. And then all we do is we connect up the two intersection points with a straight line. Just like that. And if you've done it correctly, then this will be at right angles, and these two lines will be identical, they'll be equal in length. So that is the perpendicular, because it's at right angles, and bisector, because it cuts the line in half. Question 6. Oh no, the second hardest topic to do online, because I don't have tracing paper. But don't worry, we can figure this out. It's asking me to rotate this triangle 180 degrees about the point 1 along minus 1 down, so about this point. Okay, so without tracing paper, what I would do is I would draw a like an L shape, and then I would rotate that L shape around. So it would look like that. So that means that that point is now right here. Okay, I'll draw another L shape to the other point, and then I'll rotate that. I'd imagine that L rotating around, and it would look something like this. So that means this is our other point, and then finally I would do the same thing again like that, and I would imagine that rotating around, and that would look like that. And then I would get rid of these construction lines, we don't need those, and I would then just draw the triangle, and I would label it B, like they've asked. Beautiful. Okay, now it's asking me to translate, which means to move the object -7, 3. So what I do is I highlight the corner I'm moving, and then I go 1, 1, 2, 3, 4, 5, 6, 7. That's to the left because it's -7. And then the 3 represents up or down because it's positive, we're going up. And that is 1, 2, 3. So that becomes my new corner. Now the biggest mistake people make is they draw the shape now, but they draw it from a different corner than the one they've moved. Because I've drawn this corner on here, I know exactly where to start my shape and how it should look. And it should look like that. And that is labelled C. Fantastic. Okay, question 7, we're looking at averages, and we've got a list of 6 numbers written in the order of size. The numbers have a range of 9. Okay, so they're in order of size, which means the range is the biggest minus the smallest. So 12 minus x must equal 9. So from here, I can tell that x must equal 3. Okay, the median is equal to 8. Now the median is the middle number, and here we've got 2 middle numbers. It's a bit of a problem, but what we do is we add them up and then we divide by 2 to find the average of those 2 middle numbers, and we're told that's equal to 8. So rearranging this equation tells me that y plus x must equal 16. Okay, so more information needed. Aha, here it is. The mode is 10. That means that there must be another 10 lurking around, and that must be z because that's bigger than y. So therefore we know that z is equal to 10, so therefore this equation now becomes y plus 10 equals 16, which means that y must equal 6. So there we have it. X is 3, y is 6, z is 10. Bosh. Frequency tables. Okay, so a frequency table tells us, in this case, there are 80 students entering a dance competition, and it tells me the length of time for which each student spent dancing. Okay, so what we need to do is we need to write a new column called midpoint, because that's going to be the average that each person in that row spent dancing. So here it's going to be 6 because it's halfway between 0 and 12. The next one is going to be 18 because that's halfway between 12 and 24. This next one will be 30. This one will be 42. And this one will be 54. Okay, nice and neat there. And then this column is going to be called the midpoint times by the frequency. So this is going to give us an estimate for the total amount of time that all, in this case, these 11 people spent dancing. Well, we assume they spent 6 minutes each. So we do 11 times 6, and that gives us 66 for the total time those people spent dancing. Next one, and I'm going to need the old calculator here, is going to be 25 times by 18. 450. 30 times 23, 690. 15 times 42, 630. And 6 times 54 is 324. So it says work out the estimate for the mean length of time. Okay, so what we're going to need to do is add up all of these numbers. So 324 plus 630 plus 690 plus 450 plus 66. So that gives us 2,160. That's the total time that all the people spent dancing. And we're going to divide that by the total number of people. Now, most people make a mistake by writing 5 here. They divide by 5. Oh gosh, no, that's a bad idea. They think there's 5 rows, so that must be how many people there are. That is not the case. The number of people is the total of the frequency, which in fact we're already told is going to equal 80. So we divide through by 80. So we divide by 80 and we get 27. We do a little sense check. Does that seem about right? Well, it's certainly within the range of 0 to 60. It's about halfway. Sounds good to me. Okay, question number 9, and it says in a box there are only green sweets, orange sweets and yellow sweets. There are 280 sweets in the box so that the number of green sweets to the number of orange is 2 to 3 and the number of orange to yellow is 1 to 5. Okay, so what I'm going to do is I'm going to write green, I'm going to write orange, and I'm going to write yellow in that order. Okay, so green to orange is 2 to 3. And orange to yellow is 1 to 5, which is also the same as 2 to 10. That's not helpful. It's also the same as 3 to 15. Now that is helpful because I want the oranges to line up with these oranges, and they have done. So that means I can say that the to yellow is to 15. That works perfectly. So now we've got a ratio that combines all of the colours. So we can add up the total ratio, and that gives us 20. And then we can take the total and divide it by the number of, well, shares. And that means that each share is worth 14. So how many green sweets are in the box? Well, green has 2 shares, so green is equal to 14 times 2, which is 28. Beautiful. Okay, standard form. So we've got 10 to the minus 4 there. So what I'm going to do is I'm going to write 6.25 and I'm going to move it backwards 1, 2, 3, 4 spaces. There's the new decimal point. So we've got a 0, 0, 0 and a 0. So it's 0.000625. Top tip, whenever you've got negative power of 10, they're always going to be the same number of zeros. 1, 2, 3, 4. Only negative though. Okay, next up, we are working this out. Now, I suspect the calculator might not help us, but we could try. So we can press 2.4 times 10 to the 12 divided by 9.6 times 10 to the 4. Aha. As suspected, it's not going to give us it in standard form. I need to check there. It looks to me like there are 6 zeros. 1, 2, 3, 4, 5, 6. Hopefully my eyesight is right. I'm going to go with that. Okay, so what is that? That's 25 million. How do I write that in standard form? Well, it has to be between 1 and 10. So I've got to use 2.5. I can't use 25. So if the decimal point is there, I need to move it 1, 2, 3, 4, 5, 6, 7 spaces to get to it to where it needs to be. So it's 2.5 times 10 to the 7. Okay, percentages. Shane bought a car. The amount he paid for the car was 32,000. Teresa also bought a car. To pay for this car, Teresa paid a deposit of 18,000 together with a 14 monthly payments of 1,160. Teresa paid more for the car than Shane did. Work out how much more Teresa paid as a percentage of the amount Shane paid. Wowzer. Okay, well, first off, let's work out how much she actually paid. So it's 1,800 plus 14 times 1,160. So 18,000 times, plus 14 times 1,160. Okay, so that is 3,4,240. Now, they want to know how much more. So we need to subtract how much Shane paid for the car to find how much more she paid. So if I subtract 3,2,0,0, then that's how much more she paid. And then they want that as a percentage of the amount Shane paid. So I need to do this out of 3,2,0,0 and then times by 100 to make it a percentage. So divide by 3,2,0,0 times by 100, and the answer is 7% more. Okay, Kylie bought a van. After 1 year, the value of the van was this much. During this year, the value of the van decreased by 15%. So the first thing I do, whenever I see that, I will always just write down what a decrease of 15% is, and it's 0.85. That's what I'm going to be using. So I'm not tempted to do something else. Work out the value of the van when she bought it. Okay, so it was worth something when she bought it, and then it was reduced by this amount, and that equaled the new amount. So to reverse this process, I must divide by that multiplier. Common mistake is that people increase the new amount by 15%, hoping it will get back to the start. That is not correct. You must divide by the original multiplier. So this gives me 4, a nice round number, which makes me feel confident is correct. Perfect. Okay, next question is on compound interest. Matteo is going to invest 5,000 Swiss francs for 2 years. He can invest his money in bank G or H. The total amount of interest Matteo would receive at the end of 2 years from G is more than the amount of interest he would receive from bank H. How much more? Okay, so let's start off with G. it's 5,000 times 1.016. That's a 1.6% multiplier. To work out multipliers, what you can do is always start with 100, add on the percent you want, and then divide it by 100. And that will give you 1.016. And that is for 2 years, so I need to square it. Okay, yeah, we can do that now on our calculator. 1.016 squared, and we get 516.1.28. Okay, great. And then what is this bank doing over here? H, 2.9% interest added after 2 years. Okay, so that's just doing a single multiplier, which will be 1.029. That's just doing it once because you just get it at the end of the 2 years. So it's not compounded, it's just a single interest payment at the end of 2 years. That is 5145. Okay, so what we need to do is just find the difference between the two. So if I just subtract this from this, that is the difference. So that's how much extra interest Matteo will receive. I'll just show my working, just so the examiner knows what's what. And that's my final answer. Similar shapes. We need to find a common corresponding pair of sides, and these two are corresponding, so we can find the scale factor by doing the larger one divided by the smaller one. And let's just get that on our calculator. So 9.6 divided by 6 gives me 8/5, which is 1.6. And we need to find GH. Where's GH? It's this one over here. So we're going to take the larger one and we're going to divide it by the scale factor to find X. So X will be 4/1.6, which is 2.5. And then BC. BC is this one up here. Let's call it Y. This time we're going from small to big, so we're going to multiply by the scale factor to find Y. So Y is equal to 5.7 multiplied by the scale factor 1.6. Nine 0.12. Okay, great. Okay, expanding brackets. I am going to start with the square bracket here, which will be 2x minus 5 times by itself. So it'll look like this. Okay, so let's expand that out. So first off, that's going to give me 4x squared, because there are two x's, so it makes x squared. That's going to give me minus 10x. This is going to give me another minus 10x. And this is going to give me two negatives times together to make a positive, so plus 25. And I've still got this 3x there. Okay, so what I could do is I can collect the x's. There are two minus 10x's, so that makes minus 20x. Okay, now that's as simplified as it can get. Let's just multiply each term by 3x. So that's going to give me 12x cubed minus 60x squared plus 75x. And we're done. Okay, let's factorize fully. So there are quite a few things we need to do here. First off is look at the numbers. Now, what is the highest common factor between 18 and 21? Well, that's 3. because 6 doesn't work. Okay, so it's definitely 3. Now let's look at the c's. We've got a c cubed and a c squared. So the highest factor there is c squared, the highest common factor, should I say. And d, that does not appear in both the terms, so that is enough. Okay, what have I got to times 3 by to get to 18? I've got to times it by 6, and I've got to times c squared by a c to get to c cubed, and I need to times by d squared in order to make d squared here. Okay, what have I got to times 3 by to get minus 21? It's got to be minus 7. And there's already a c squared there, so I don't need to multiply by anything else. And that's us done. Okay, question 16, or topic 16 should I say, equations. We've got a bracket here, so let's multiply it out. 3 times 2 makes 6, and 3 times minus 4x is minus 12x. And that equals 5 minus 8x. Now, my top tip is that we always look for the smallest x term, which in this case is minus 12x, is the most negative. And we add 12x to both sides to cancel it from that left side. So that cancels with that. That leaves me with just 6 on the left side, and we have 5, and minus 8x plus 12x is plus 4x. Now we can take 5 from both sides here. Cancel, cancel. This leaves me with 6 minus 5 is 1. And we're left with 4x over here. And then finally we can divide both sides by 4. So we get x is equal to a quarter. Okay, inequalities. Write down the inequalities shown on the number line. So this one is at 3. X is the variable, and we're going to the left here, so it's all the terms which are less than 3 or equal to, because it is a filled in dot. If that was a hollow dot, then it would be just less than, not less than or equal to. Okay, let's solve this inequality. Again, what we're going to do is look for the smallest, in this case w term, so that's 7w. We're going to take 7w from both sides to cancel. So cancel, cancel, and that leaves me with 6 on that side. 12w minus 7w is 5w plus 14. We're going to subtract 14 from both sides to try and isolate the w. Cancel, cancel, so that leaves me with minus 8. Minus 8, yes, minus 8. Why did that take me so long? I don't know. Is greater than 5w, divide through by 5, and we get this. You might want to write it this way round, it looks a bit better, but I think you would be fine and get the marks either way. Okay, so w is less than minus 8 over 5. Okay, we've got inequalities on a graph. So let's just scroll down. What's the question asking us to do? It says the region shown in the diagram is bounded by the straight lines with these equations. Oh, that's nice of them to give us the equations. Write down the 3 inequalities that define R. Okay. So I'm going to start with the first line, and I need to identify which one it is on the graph. So if I substitute in if I rearrange it so that it's y equals, I'm going to get y equals minus 2x from both sides. So I get it in this form, y is equal to minus 2x plus 6, which is great because it's in the form y equals mx plus c, so I can see what the y-intercept is, and that y-intercept is 6. So this is the green line. It starts with the y-intercept of 6. Now I want my region to be below that line. My region is below the green line. So I write that y is less than or equal to minus 2x plus 6. Because it is below, we write less than. Okay, next one. Again, I'm going to rewrite it by dividing through by 2. And that way, hopefully, it'll be easier for me to check to see which graph that one is. Well, actually, that one's quite easy. It's the only one with a positive gradient. So I know for certain it's going to be the one that's going from left to right. It's going upwards. And again, you can see the region is below that, that yellow line. So therefore, I need to, again, write less than or equal to. Like such. And then finally, keeper of tradition, I will colour this one in blue. And I will confidently select that line there. But just to keep with the same logic, I'm going to move it over so that it becomes y equals. And that way, I just keep it nice and consistent with what I'm doing. So divide through by 3 like that. And now this time, you can see the region is above the blue line. So therefore we write y is greater than or equal to minus 2 over 3x plus 4 over 3. Okay, right, hopefully that explains it. Okay, classic simultaneous equations. Let's line up the y's because I can do that just by multiplying the bottom one by 4. So I keep this one exactly the same, and I times this one on the bottom by 4, which is going to give me this. Okay, now because the signs are different with the y's, it means I need to add the two equations, because that will cancel out the y's nice and neatly. This gives me 13x, again, the positive 4y and the negative 4y, add them together, cancellation. And over here, we're going to get 15.6. I'm going to have to do that division on my old calculator, but I reckon that's 1.2. Nice. Come on. X equals 1.2. Now that needs to be substituted back into one of the original equations. And I think I'm going to go with the... which one? I'm going to go with the... I'm going to go with the bottom one. So 2 times 1.2 minus y is equal to 4.4. Of course you go with either, it doesn't make a difference. Times that out gives me this. Minus the 2.4 from 4.4 gives me 2. And then divide by minus 1 gives me minus 2. So there we have it. That is my solutions. Okay, indices. Right, when we multiply any numbers that have the same base, then we need to add the powers. So I'm going to be adding a half to 2/5, which is the same as 5/10 plus 4/10. So that is 9/10. So that means that m is 9/10. And when we're dividing powers, terms, then we need to subtract the powers. So we need to do minus 10 minus minus 4, which is minus 6. Okay, short and sweet that one. But indices, big topic. So make sure you do watch the extra videos on indices because it's a really common topic, and I've got lots of good questions on it. Yay! Measures, and this time we're looking at speed. Again, you could get questions on pressure or density, or even just converting units like centimeters squared. So check out my other videos for that. Now, what is this? So this is 90 kilometers per, and per means like every, out of, divide, 1 hour. Okay, so let's just convert this. I mean, what's 90 kilometers? 90 kilometers is 90,000 meters. And what's 1 hour? Well, 1 hour is 60 minutes, which is 60 seconds. 1 hour is 60 minutes, of which there are 60 seconds in each minute. You get what I mean. So all we need to do is 9,000 over 60 times 60, which gives us 25. Beautiful. Angles. Okay, what have we got here? We've got a pentagon. Thank you for letting me know. A pentagon has how many degrees inside? Well, if you're not sure, you can always use the formula to work out the total area inside of a polygon. Sorry, not total area, the total angles, the total interior angles. So in this case, we take pentagon has 5 sides minus 2 and times it by 180. And this gives me 540. Okay, so what do we already know about this shape? Well, we know that they add up to 540, and we have inside there x and a 90-degree angle, and a 135, and a 67, and a 119. So we go to our calculator and we add up 119, 67, 135 and 90, which gives us 411. So we write this equation like such. We subtract 411 from both sides, and that will give me my answer. Whoops, which is 129. Perfect. Lots more questions on angles, such as alternate angles, parallel lines. So make sure you check out the extra videos. Topic 23, angles in polygons, and this is a little bit of a corker. I mean, you don't normally get them this tricky, but anyhow, let's get on with it. We've got 5 sides of a regular polygon. We've got RST, blah, 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 blah. They're all straight lines. So everything's straight lines. And RST is parallel to CD. And we've got the angles in there. Work out how many sides this polygon has. Okay. This is good because in the last topic on angles, I didn't cover parallel lines, which is a big part of it. And here we're going to cover it. Because this here, like what I've drawn in blue, makes a Z. So that angle there, covered with this angle here, makes a Z, and that means that these two are alternate angles. So that is 128. Now the line SU is a straight line, which means we could work out this green angle in here, because 180 is a straight line. So if I minus 32 and minus 128, I'll be left with that green angle. So 182 minus 32 minus 128, that's 20. And that is the exterior angle of the polygon which we are looking at. Because remember, an exterior angle comes straight out the side of the polygon, and that will be my exterior angle. And if I just draw them all like this, what you'll notice about exterior angles is they go all the way around the shape. So therefore, they must add all up to 360. So the number of sides is going to be 360 divided by the exterior angle. So that's 360 divided by 20, which is 18. So this is an 18-sided shape. Okay, bearings. So we have the bearing of Paris from London is 149. Okay, so let's do this the long way, just so we can show the understanding. So Paris from London, which means this is London where we're starting, and this is Paris down here. And if I measure it from north, which is how bearings are measured, and if I measure it clockwise, again, how bearings are measured, then that is 149. Okay, so what does that mean I need to get back the other way? Well, again, I must always go from north and I must always go clockwise. So I need this angle around here. Now I can work out what the green angle is because these two north lines are parallel, which means that the angles inside the two parallel lines must add to 180. So we get this sort of equation like that, which means that the x, the green x, is equal to 31. Okay, which means that the orange angle, which is the bearing we're looking for, is 360 minus 31, which is 329. Now the shortcut method is to know that bearings going the opposite direction always differ by 180 degrees because you just turn around to go the opposite way, so you must change your angle by 180. So if I take 149 and add 180 to it, then that gives me a total of 329 straight off the bat. Bosh. Okay, a little bit of Pythagoras here. Classic type question. You draw a straight line down off of the isosceles triangle. Okay, and it has a base of 24. So if I just draw one side of this triangle, then it's going to have 12 along the bottom and it's going to have a height which we don't know yet. But what we do know is are these two sides. We know that because the perimeter is 54. So 54 plus 24 plus x. We know these x's are the same because of these lines here. So that means 54 is equal to 24 plus 2x. So 30 is equal to 2x. So 15 is equal to x. So this side length is 15. Now here comes the Pythagoras. We know that the two short sides added together and squared is equal to the long side squared. So rearranging this equation, I can subtract the 12 squared from both sides, and then to find h, I can square root my answer. So on my calculator, I type the square root of 15 squared minus 12 squared. And this gives me an answer of 9. So the height is 9, and now we can do what the question asks, which is find the area. So the area is a half base, which is 24, times height, which is 9, and this is going to give me 108 centimeters squared. Okay, number 26, getting tricky with it. Right, it's trigonometry, and we are looking at a right angle triangle, and we need to label the sides. So the angle is here, so this one is opposite the angle. The right angle is there, so this one must be the hypotenuse. And then finally, the 18 is the one which is adjacent to the angle. Okay, so what do we actually need to solve this question? Well, we're looking for the perimeter of the semicircle, so we're going to need the diameter of the semicircle. So we're going to need this line here, which is the hypotenuse, and we already have the adjacent. So we are looking at cosine, because cosine of the angle is the adjacent over the hypotenuse. And we are trying to find the hypotenuse, so I cover the hypotenuse, and this tells me that the hypotenuse is equal to the adjacent over cosine theta. So the adjacent is 18 over cosine of the angle, which is 50. Okay, into the calculator we go, and we do 50 over cosine of 50. No, whoa, what am I doing? Slow down there. 18 over cosine of 50. There we go. And that gives me 28 pretty much exactly. Okay, great. So the semicircle, well, the circumference of a circle is equal to 2 pi r. But I want just a semicircle, and I also want to add on the diameter itself, because if I find the half of the circumference, it's going to give me this, but then I have to also add on the diameter to get the total perimeter. So the perimeter is equal to 2 pi r divided by 2 plus the diameter, which essentially is 2r. Okay, so therefore this is the same as 2 times pi times the radius, which is 14. That gives me the circumference of the circle. I need to divide that by 2 because it's a semicircle, so I get 14 pi, and then I need to add on 2 lots of the radius, or also known as the diameter, which is 28. And we get an answer which is pretty much 72. At least it is to 2 significant figures. Job done. Okay, again, the last couple of questions, they've all been very similar because these topics do interlace quite a lot. Anyhow, area and perimeter, work out the perimeter of this shape. Well, we're going to need to use Pythagoras' theorem, aren't we, to find this hypotenuse here. So 6 squared plus 6 squared is equal to h squared. So the square root of 6 squared plus 6 squared is going to equal h. So that is going to be the square root of 6 squared plus 6 squared, which is 6 root 2. And I might just leave it like that as a surd, actually, keeping the full exact value, because I feel like I'm going to have to use that quite a bit. Okay, well, let's first off find this semicircle, given that we've just found its diameter. So the radius of that semicircle is going to equal half of 6 root 2, which is 3 root 2. So the perimeter of that semicircle is going to equal 2 times pi times the radius, but then I need to divide that by 2. Okay, in fact those will cancel, so this is just the same as 3 pi root 2, which we can find a value for. But to be honest, I'm just going to probably leave it in the exact form. But there you go, it's about 13.3. Okay, now that is the green bit. Let's find the blue bit, which is actually exactly the same as this blue bit. So in fact, it's just one full circumference of a circle with radius 3. So it's just 2 times pi r, so it's just 2 times pi times 3. So I'm just going to do that. So 2 pi times 3 is going to give me 6 pi, which is 18.8. Okay, so the total perimeter is 18.8 plus 13.3. And that gives me 32.1. Lovely. Okay, volume and surface area. We're asked for the total surface area of this triangular prism. So what I'm going to do is I'm going to split it up into the 5 sides, and I'm going to work out the area of each, and then I'm going to add them up. So side 1, let's start with the base. and that will be 3.6 times by 7. And then let's go to the back for side 2. So that's 4.8 times by 7. And then let's go to the slanted front side, which is 7 by 6. So 7 by 6. And then we have the triangle here, which is a half times base times height. And then we have another triangle at the back, which is exactly the same. Okay, so what we need to do is just add all of these up. So I'll do 3.6 plus, 3.6 times 7 plus 4.8 times 7 plus 7 times 6 plus, well, I've got 0.5 times 3.6 times 4.8, and I'm going to plus on another 0.5 times 3.6 times 4.8. Okay, great, and we get a total surface area of 118.08, and that is centimeters squared. Check out my other videos, because I know that question just did surface area, and of course volume as well is just as important. Whoa, steady up, hold up, before you slam me in the comments. 3 significant figures, so that is just as such. Okay, cumulative frequency. The cumulative frequency graph gives information about time in minutes each of the 60 people took to shop in a market. How exciting. Use the graph to find an estimate for the median number of people. Okay, so there's 60 people. The median occurs at the 30th position. We draw a line across. We hit the graph. We come down. And that to me looks like 44 minutes. Happy with that? Make sure you draw the lines on the graph. I can't stress that enough. Use the graph to estimate the number of people who took longer than 55 minutes. Okay, so we go up from 55. I hope that's about 50. I hope that's 55. Should be good. Eyesight's not as good as it used to be. Go across. That looks about right. It's not really a straight line. Okay. Okay, it looks like in between values there. I'm just going to go with 49. I'm just going to say that's 49. So the number of people above that is 11. As long as you've drawn your lines on nice and clearly, you will be given the benefit of the doubt for 1 or 2. So 11 I'm going to go with there. Okay, there's more. Use the graph to complete the cumulative frequency table to give information about the time in minutes each of these 60 people took to shop at the market. Oh God, I've never seen a question where you have to reverse engineer it. That's horrible. Okay, that is really horrible, because you just got to look at the graph, and the first one is 3, as they've already told you. The next one is 8, which means the gap between them is 5. So we've got 3 and 5. And then the next one is 15. So from 8, that's a gap of 7 to get to 15. So 7 is the next number. I might just do all of them and then transfer it to the table. So this one looks to me like 25. So that's a gap of 10 from the 15 previous. And at 50, that to me looks like 40. So from 25, that's a gap of 15. 60, at least they've done nice round numbers. That to me looks like 55. So from the last one, which was 40, that's a gap of 15 as well. Okay, and the last one is obviously going to take you up to 60. So from 55, that's a gap of 5. Okay, so let's just fill these in the table. I believe the last one was 5, and there were two 15s. And then there was a 10. Okay, there you go. Okay, number 30, we've got straight line graphs. So write down the equation of this straight line. So what I'm going to do is I'm going to pick a point here, and I'm going to go 1 in the x-axis to the right, and I'm going to ask myself, how do I get back to the line? I have to go down 2, which means this has a gradient of -2. And then what is the y-intercept? Well, where does it cross the y-axis? It does so at +4. So that is my straight line. Y is equal to -2x plus 4. Okay, little bonus question. It says we have a midpoint. Now the formula for the midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So we find the average of the x coordinates and the average of the y coordinates. So in terms of the x, we have 6 plus 17 over 2, and that's going to be 23 over 2, I believe. Yeah, 6 plus 17 is 23, so over 2. Don't know why I used the calculator for that. And the y, well, that's going to be 4 plus j over 2. But we know that it's equal to 15, so we set up an equation. 4 plus j over 2 equals 15, which means 4 plus j is equal to 30, which means that j must equal 26. Okay, great. So j is 26, and k is the x-coordinate of the midpoint, which is 23 over 2. Okay, sketching graphs. Tricky one this, but we can use our calculator to help us with all these nasty substitutions, which I recommend given how kind of tricky this one is. So we write table on our calculator, we go to table function, and then we do 2 over, we press alpha, and this button here, which is above the right bracket, and that gives me the x. And then we're opening up a bracket and doing 5 minus 1 over, again press alpha, x, and that to me looks like the function. We don't need a second function, so we just press equals. Now this one starts at 0.5, it ends at 5, and sorry, I just pressed the wrong button there. And we need to go up into steps of 0.5 in order to get all of the ones which we actually need. Okay, so now we read across. So at 0.5 we can see the f of x value is 12. And in fact we only need, so I didn't realise, we only need one extra value, we need 2 values, 4.5. That's the one for 2. Okay, well that's that done. And now we can plot. So at 0.5 we get 12. So I'll plot at 0.5 12, like so. And at 1 we get 8. 2 we get 4.5, which we have to be careful. It's not in the middle of 4 and 6. That would be 5 right there. It's in the middle of 4 and 5, which is here. And then at 3 we get 3.1. Gosh. Well, 3 is here. Each step up is 0.2, so it's halfway up a square. So we'd be really precise with this graph. And then 2.4, each point is 0.2, so it's 2 little mini squares up from 2. And then 1.9 is half a mini square below 2. Okay, and then we always must connect up the graph. Now this is going to be a smooth curve. That's about as smooth as I can get it. And that's it. Okay, quadratics. We need to factorize this. 2 numbers that times to make minus 18 and add to make minus 3. Well, if you're struggling, what you could do is you can write out the factors of 18, like so, and try and find one which has a difference of 3, and that is 3 and 6. So we're going to write y minus 6 and y plus 3, and that will give us our correct factors. Now we solve for when it equals 0. So after factorizing, we know that equals 0. So either y minus 6 equals 0 or y plus 3 equals 0. Well, if y minus 6 equals 0, then y equals 6. And if y plus 3 equals 0, then y equals minus 3. Quadratic inequalities. This is going to test quite a bit of skills here. First thing we're going to do is move everything over to one side to make it equal 0. And then we need to factorize this to solve this inequality. And in order to do that, I am going to use the AC method, which is timesing A by C, and that gives minus 210. And then I'm also going to write down what the B term is. So I'm looking for 2 numbers that times to make minus 110 and add to make 32. So the 2 numbers I'm looking for are 42 and minus 5. Yes, that works. Okay, so this is my method for solving quadratics by factorizing, and we've got a tricky A term. I write 6x, 6x, all divided by 6. And that is because the A term is 6. We put those 2 numbers in, which were plus 42 and minus 5. I then need to take out a factor of 6 or divide one of these brackets by 6. I can do that to the left one, and that gives me this. And I want this to equal 0. I want to find where these critical points are. So x equals minus 7, and this one would be x equals 5 over 6. Now what we do is we do a quick sketch of a quadratic. And I know that it has values at 0 of minus 7 and 6 over 5. And I also know a quadratic has this shape to it, like that. So the question now becomes, when is this quadratic less than or equal to 0? When is it below the axis? When does it give us negative values that are below the axis? Well, that is in between minus 7 and 6 over 5. So that is my final answer. Check out my other videos on quadratic inequalities if you want to see what happens if the quadratic inequality is greater than. We look at the other sides rather than the bit in the middle. Okay. Okay, here are 9 cards. Each card has either a number on it or a letter on it. Thomas is playing a game. Thomas takes at random one of the cards and keeps it. Thomas then takes at random another card and keeps it. Wow, what a fun game, Thomas. Okay, complete the probability tree diagram. First card is a number. Well, how many numbers are there? 1, 2. That's it. So it's 2 out of 9. Excuse me, how many letters are there? Well, that must be 7 out of 9. Okay, now if he's taken a number, then that means there would only be one number left, and there'll be 8 cards to choose from. And if he has taken a number, there would still be 7 letters left, but there would be 8 cards to choose from. Now, if he took a letter, then there would still be 2 numbers left, but only 8 to choose from. And again, if he took a letter, then there would be only 6 letters left, but 8 to choose from. Okay. Work out the probability that each of the 2 cards has a number on it. So a double number means you need to go down this branch of the tree diagram, and the probability of number will be 2 over 9 times 1 over 8, which is, it's 2 over 72, which is equal to 1 over 36. Work out the probability that there will be 1 card with a number on it and 1 card with a letter on it. Okay. Well, that can happen 2 ways. He could do this branch, or he could do this branch. So what are the chances? So the first one is 2 out of 9 times 7 out of 8. Which is the same as 7 over 36. Or this one, which is 7 over 9 times 2 over 8, which is also 7 over 36. So because he could take either of those roots, we need to add those 2 probabilities together. So the probability is 7 over 36 plus 7 over 36, which gives us a total of 14 over 36, or 7 over 18. That is a classic tree diagram question. New type of question, Edexcel IGCSE. Not seen this in the first sort of 4 years of the papers, but they are asking to find A to a suitable degree of accuracy. Okay, let me explain. Now, a lot of the time you might get an equation like this and they might ask you to find A upper. And in doing so, we would need to take V upper. Because we are subtracting U and we want the overall to be as big as possible, we're going to take away the smallest possible U. And because we're dividing by t, we need t to be as small as possible in order to make our overall value as big as possible. So what is V upper? Well, it's rounded to 2 decimal places. So the upper bound will be 45.235. That's the upper bound to 2 decimal places. The lower bound of U to 2 decimal places will be 5.115. That's the smallest possible value, which will round to 5.12. Okay, and the lower bound of T would be 8.45. Because again, that's the smallest possible value, which would round to 8.5, given 2 significant figures. Okay, what we do is we find that out. So 45.235 minus 5.115, and then divide that by 8.45. Okay, and I want the decimal expansion of that. So that is 4.7479. That should be enough. Okay, and then what we have to do is we have to do the lower bound. And the reason why I know this is because it says by considering bounds. So I've got to find both the lower and the upper. Okay, so the lower of A would be V lower minus U upper over T upper. So that would be 45.225 minus 5.125 over 8.555. 8.55. There's lots of opportunities to make mistakes here. 45.225. I just hope I haven't made one. 5.125. And then divide that by 8.55. Right, we should get a value which is similar, but obviously lower. Okay, now what we do is we need to find the degree of accuracy in which the lower bound and the upper bound round to the same thing. So let's try 2 decimal places. Well, the upper bound rounded to 2 decimal places would be 4.75. The lower bound would be 4.69. Are they the same? No, they're not. So that is not a suitable degree of accuracy. 1 decimal place, let's try that. Upper bound, 4.7. Lower bound rounds up to 4.7. Fantastic. So therefore, we say that the answer is 4.7. A is approximately 4.7 to 1 decimal place as the upper and lower bounds are the same to 1 decimal place. There we go. Answer the question, show my working, and given a reason for my answer. Bosh. Okay, circle theorems, huge topic. Definitely check out the extra exam questions and my explanations in my video where I cover all of the topics so you know what is going on. Okay, but this question, DCB is what we're looking for, which is this angle right here. Now that angle is part of a cyclic quadrilateral, which I could just draw on here, this quadrilateral. So we know that the opposite angles add to 180, so therefore it's 180 minus 40, which is 140. Okay, I'll give reasons. Can I bother to write it down? Do you want me to write it down? Probably not. Let me write it down, pause it, and then repause. There you go. Just saved 20 seconds of your life. You're welcome. Work out the size of the angle ADO. ADO is this angle in here. Okay, well we've got some funky business going on with this 66 and a tangent, and we know they meet at 90 degrees, tangents and radius, so therefore we know this angle in here must be 24, because those two must add to make 90. We know already that this is 140. Actually, that's not going to be helpful, but we know this angle up here is 40, and angles at the center are double angles at the edge, so that's 80 there, which means this reflex angle is 360 minus 80, which is, of course, is 280. So now we've got 3 of the angles inside this arrowhead, so we can work out the fourth angle, which is what we need. Okay, so it's 360 are the angles inside the arrowhead, because it's a quadrilateral, minus 24, minus 280, and minus 40. calculator, please. $16. Yay. Okay, this looks like a beast question, and it is a beast question. It's a 23er. But hey, why not? Let's do it. Work out the size of angle ADE. So we're looking for this angle in here. I'm going to call it theta. And we know our chord theorems go a little bit like this. This is the intersection point, so I must make sure I use that in every term of the theorem. So that's AE times by CE is equal to BE times by DE. Okay, so that's x plus 5 times by x minus 12 is equal to x times by x plus 12. Yeah, that's right. I think I said that right, but I've definitely written it down right. Okay, great. So this could be solved. It's going to take a bit of legwork, but it can be solved. We'll expand the brackets to get 5x squared minus 12x plus 25x minus 60 is equal to x squared plus 12x. We will get some more space. We'll minus x squared from both sides. We will collect up these x's, so I get plus 13x on this side, and I'll just keep the 12x over there for now. Move it back over, so that gives me plus 1x and minus 60. Okay, so let's do AC method. So 4 times by minus 60 is equal to minus 240. And the B value is equal to 1. So I'm looking at 16 and 15 here. But the A term is 4, so I do 4x over 4. And I believe we've got plus 16 and minus 15 should do the job. Just double check quickly. Apologies. 16 times 15 is 240. Yes, it is perfect. Okay, great. Divide through by 4 gives me x plus 4 and 4x minus 15. X equals minus 4 or x equals 15 over 4. Okay. Now, x can't be minus 4 because x is a distance and we can't have a negative distance. So we know that x is 15 over 4. So now let's look at this triangle, and we have 15 over 4 plus 5. 15 over 4 is the same as 3.75. So plus 5 to it gives me 8.75. And if I plus 12 to it, that gives me 15.75. Okay, so this is good. We have one side, we have two sides, and we have an angle. So we need to use the sine rule here because we have a pair of side and angle which are opposite each other. So using the sine rule, I'll do it up here to save space. Sine theta divided by its opposite side, which is 8.75, is equal to sine of 48 over its opposite side, which is 15.75. Okay, so on my calculator, I will rearrange to find what sine theta is. So I will do sine of 48 over 15.75 multiply, because I want to clear that denominator, so I need to multiply that all by 8.75. Okay, great, so I get 0.4129. So then to find theta, the angle I'm looking for, I need to do sine to the minus 1, the inverse function of sine of that value. So I just type in my calculator, shift sine of the answer, and I get 24.4, and that is correct to 1 decimal place. Wow, what a lovely question. Bosh. Okay, I've got a set theory question here. We've got the universal set, that is all of the numbers that we're going to be using. A is even numbers. The intersection is 12, 16 and 20. So that's the centre or the middle part of A and B. It tells me that everything which is not in the union is 17 and 19. So that means that these are all the ones that need to go outside because they're not in the union, and the union is everything inside A or B. So they need to go on the outside. A are even numbers, so any number which has not been written down and is even must go in A. So that's 14 and 18. And then any other number has only got one other place to be, which is this place in B. So 11 must go in there. 13, yep. 15, yep. 17, no. And 19, no. And that's it. That's a wrap. Okay, beast question. Venn diagrams. Okay. Now we've got the number of elements in these given areas, and we need to complete the Venn diagram to show the number of elements. So slightly different to the last question that we've just done. Okay, we're always going to want to start with the centre, and that is given here. The number of elements in the intersection of A, B and C is 5. So that means 5 goes here. Next one. The number of elements that intersect with A, B, and not C is 2. So that's this area here. The ones that are in A and B, and they're not in C. And then here we have the number of elements in A and C is 5. Cheeky. So A and C is this area here. And it's saying that there are 5 in there. Well, we already know we've already put 5 in this part. So this part here must be 0. So there is 5 in the intersection of A and C. Very cheeky. The number of elements in A is 17. So that means inside this circle needs to add to 17, which means that must be 10. The number of elements in A union B, union C, not is 3. Okay, so the union of A, B, C is everything that's inside A, B, or C. And it's saying what is not in there, because this dash means not, is 3. So that means that 3 goes on the outside. There are 3 elements that are not inside A, B, or C. This question is so tricky. The number of elements that are not in A, and in B, and not in C is 6. So that must be this area here, because these are all the ones which are in B and are not in A and are not in C. So they can't be in any other place other than just only in B. The intersection of B and C is 7. Okay, so again, the intersection of B and C is this area here. We've already got 5 in there, so to make 7, this must be 2. And the number of elements in C is 14, so that covers all of these elements here. We've already got 7 in here, so this must be 7 to make 14. Okay, number 40, rearranging. Such an important skill this, particularly if you want to go on to study A-level maths. You've got to be really fluent at working with your algebra. So we want to make E the subject, so let's get rid of that square root by squaring both sides of this equation. And now denominators are our enemy. We want to get rid of them by clearing them by multiplying both sides by the denominator. So this gives me in brackets w squared times EF minus D. And that's cleared the denominator on that side. I'm then going to want to expand these brackets like this. And then here comes the most important part, which is that we need to get the e's on the same side. So there are 2 terms there which have an e in it, and we need to make sure they're on the same side. So what I'm going to do is I'm going to minus e to both sides, and I want to get rid of anything which doesn't have an e in it. So I'm going to add w squared d to the other side. Is that a g or a y? It's a g. Plus w squared d. Okay, great. I've got my 2 terms on this side which have an e, and that allows us to factorize, which is the key part of rearranging when the variable we want to make the subject occurs twice. This gives me w squared f and then minus 1, because to take an e out of just e, you're left with 1. And that's g plus w squared d. And then we can divide by that factor, which gives you w squared f minus 1. Okay, it's not the only way to do it. Sometimes you might have worked through and you might have got this as an answer, where all the terms have a different sign. If that's the case, that is still correct. But this one is just slightly nicer because it's got less minus signs. Okay, proof. I love these questions because you just got to read the question and then put it into algebra. So prove algebraically that for any 3 consecutive even numbers. Okay, so let's get started with that. The 3 consecutive even numbers I'm going to go for. Well, a classic even number is just 2n. And then the next one along is 2n plus 2. Because if you add 1 then that'll make it odd, so that's not an even number. And then you could go 2n plus 4, but I've learned that it's actually easier if you go 2n minus 2. So the one prior to that just tends to cancel out a bit nicer, but either's fine. The sum of the squares of the smallest even number and the largest even number. Okay, so let's do that straight away. The sum of the squares of the smallest one and the largest one. So the smallest one is obviously 2n minus 2, and we're squaring it and we're summing them because it's the sum of the squares. So let's just take a moment to work out what that is. So that's 2n minus 2 times 2n minus 2 plus 2n plus 2, 2n plus 2, which is 4n squared minus 4n minus 4n plus 4. And this is 4n squared plus 4n plus 4n plus 4. Okay, doing a few little bit of cancelling here means that we get 8 n squared plus 8. Okay, is 8 more than twice the square of the middle even number? Okay, so what have I done so far? I found this. Let's now find twice the square of the middle even number. So that will be 2 lots of the middle even number squared. Okay, so that's 2 lots of, well, 2n times 2n is 2n squared. So that is going to give me a total of 2 times 2 times 2, so that's going to be 8n squared. So that's the green one there. And it says is 8 more. Okay, well, looks to me like we have proved it. So we have 8n squared plus 8 is 8 more than 8n squared. And we're done. Okay, number 42, quadratic simultaneous equations. Okay, this is a nice one because we already have it equal to one of the variables. So the linear one is already y equals. So all I need to do is write out the quadratic one, but replace the y with, in this case, 7 minus 2x. So that goes straight in to there. And then we can expand this. So this is the same as, let's just do this over here, this double bracket expansion. 49 minus 14x minus another 14x plus 4x squared. So that's the same as 4x squared. We've got minus 28x and plus 49 equals 34. We can collect the x squareds and we can minus 34 from both sides to get plus 15. Yeah. Okay, we need to factorize this. So AC is equal to 75 and B is equal to minus 28. And I know it factorizes because they don't ask me to give my answers to like 2 decimal places or anything like that. So there must be some nice numbers. Okay, got it. So we start off, as always, we write 5x all over 5 because the a term is 5. And the two numbers are minus 25 and minus 3. Yes, that works. The left-hand bracket can be divided by 5, which cancels off the denominator. And all this equals 0. So we get x equals 5 and we get x equals 3 over 5. Okay, now to find the corresponding y coordinates. Well, this equation up here is perfect. It tells me exactly what the y coordinates are going to be. Because the y coordinates are 7 minus 2 lots of the x. So 7 minus 2 lots of 5 is 7 minus 10, which is minus 3. And maybe I will use Mr. Calculator to do this last one. A bit lazy of me, I know, but what are you going to do? 5.8. Perfect. Okay, recurring decimals. Right, this is just a standard skill you kind of have to know. It's a standard process. I like to start off like halfway down the page, and I write x equals 0.438 recurring, like that. I then multiply it by 10, which is going to shift everything up, so it becomes 4.38 3, 8, and those will continue to recur. And then times by 10 again, and that's going to shift everything up to get me 43.83, which afterwards will carry on going. And then times by 10 again is going to give me 438.38, and they will continue to recur. And now, once I've done that, I can look down my line here, and I can see is there any that have the same decimal expansion on the right? Well, yes, there are. We have this one here, 3.8 recurring, and here as well. So this is the row which we're going to use, or the rows plural, should I say. And we're going to subtract those rows. So we get 1000x minus 10x is 990x. And see, let's just colour in the whole of the row. Those decimals will cancel out. So we're just left with 438 minus 4, which is 434. And now we divide through to get 434 over 990. These are both even, so we can divide them by 2. And we get the answer. Perfect. Okay, y is inversely proportional to root x. So we write y is proportional to 1 over root x, the reciprocal, because it's inversely. If it wasn't, it would just be y is proportional to root x. This means that we can write y is equal to k times by 1 over root x, which we can write like this. And now we have a equation. So this is standard. Whenever you get an inverse proportional question, this is the first thing you do. And if it was a direct proportion, it would just be y is equal to k root x. Okay, now we need some more information to find k. We need to know some conditions. Well, we're told that y is equal to c to the 4 when x is equal to c to the 2. So we could substitute those in, replace the y with a c to the 4, and replace the x with a c to the 2. Okay, so rearranging, or should I say simplifying the bottom here, c squared and then square rooted is just c. And because it's a positive constant, we know that this is going to stay positive, and that'll be fine. Times through by c, we get c to the 5 is equal to k, multiplying both sides by c. So now I can take this part here and put k, or put c to the 5 in for k. So my equation now becomes y is equal to c to the 5 over the square root of x. And that's it. That is the formula. We have found the formula for y in terms of x and c. Job done. Okay, we've got histograms, and the skill to histograms, or the formula which we need to use, is frequency density is equal to frequency divided by class width. So we must do a second column, or an additional column, should I say, called frequency density. Okay, so we have 12 and we're dividing it by the width of this class is 2. So 12 divided by 2 is 6. We have 7 and this width is just 1. From 2 to 3 there's only a width of 1. So 7 divided by 1 is 7. 15 needs to be divided by 3, which is 5. 12 needs to be divided by 3, which is 4. And 9 needs to be divided by 5, which gives me 1.8. Okay, now we are good to do to draw. So the first width is from 0 to 2, and that goes to a frequency density of 6. So I go up to here and across. The next one has a width of 1, so it goes from 2 to 3, and that goes up to 7, which is about here. So that's that part done. And then 3 all the way to 6, and that has a frequency density of 5, so that goes up to here. And then we have a width of 3, so it goes to 9, and that goes up to 4. And then we have from 9 to 14 is 1.8, which is here, I believe. Perfect. Okay. One of the parcels that Pedro delivered on Monday is chosen at random. Using the information in the table, find an estimate for the probability that this parcel weighs more than 7 kilograms. Okay, so what we're going to do is we are going to draw a line down at 7. And we know that we need to find the area which is more than 7, so it's this area here shaded in green. Well, we know the last bar has an area of 9, and the second to last bar has an area of 12, but we are only looking at 2/3 of that bar. So if I was to times this by 2/3, that would give me 8. So the green area is 8 plus 9, which is 17. So the probability will be 17 out of the total number of parcels, which hopefully is given. No, it's not given. So we're going to have to add up the total. So that's 12 plus 7 plus 15 plus 12 plus 9. So it's 55. So it's going to be 17 out of 55. Okay, 46 similar shapes. Okay, so we've got 2 vases, and the surface area of B is equal to 25 over 64 times the surface area of A. Okay, so that means if I'm starting at A and I want to get the surface area of B, then I need to multiply by 25 over 64. And this is if I'm looking at the area, which means that is the scale factor squared. The area scale factor is always the linear scale factor squared. And we call the linear scale factor K. Okay. Now, that means that if I wanted to find how to get the linear scale factor, I would just need to square root 25 over 64. So I can do that, and I would get 5 over 8, because both of these are nice square numbers, and that's 5 over 8. So that's the linear scale factor. But we don't need that. We need actually the volume scale factor, because we're talking about volume down here. So the volume scale factor, if I wanted to convert the volumes, I would need k cubed, which is the linear scale factor cubed, which is 125 over 512. Okay, so how are we going to use this? Well, let's call the volume of vase A x, and therefore the volume of vase B will be x multiplied by 125 over 512. Because in order to get the volume of B, we've got to multiply it by that scale factor. So now I can sub that into this equation down here. The volume of vase A is x, minus the volume of vase B is 125 over 512x. And that equals 541.8. So how many x's have I got there? And don't say 2. I've got 1 and I'm going to take away 125 over 512 lots of x. So in total, I have a total of 387 over 512 x, and that equals 441.8. Okay, so let's then find out what x is by dividing by 387 over 512. Okay, so great. So that tells me that x is equal to 716.8. But that's not what we're trying to find. We're trying to find the volume of vase B, which we knew was x times by 125 over 512. So I have to times it by 125 over 512. And that gives me the volume of B is equal to 175. Perfect. Okay, beast topic. Great for A-level, great for your algebra skills. Question 26, right at the end of a paper. Bosh, let's do it. Right, we've got to factorise using the AC method. AC is 4 times minus 15, which is minus 60, and the B term is minus 17. Because the A term is 4, we write 4x all over 4. Two numbers that times together to make minus 60 and add to make minus 17 are minus 20 and plus 3. We can divide the left bracket by 4 perfectly, so that's going to divide the whole thing by 4, and that is factorised. We also need to do the same for this 2x squared one as well, so I'll do that over here. This time AC equals 2 times 3, which is 6. B is equal to minus 7. We write 2x all divided by 2. Two numbers that times together to make 6 and add to make minus 7 are minus 1 and minus 6. We can divide the right bracket by 2, which will give me this. Okay, great. And in fact, I will just use that rather than writing it out again. Plonk it there. Multiply the two things together, and let's look at the denominators. So we have 2x minus 1, and we have this difference of 2 squareds here. So hopefully, if your algebra skills are good, you know that you can spot the difference of 2 squares when you have a square, and there's a difference, so there's a subtract sign in between, and that factorizes to minus 5x, sorry, x minus 5, x plus 5. Okay, we'll leave this plus part off at the end because bid maths tells us we must multiply before we add, so let's leave that bit off for now. And we can do some lovely cancelling. X minus 5 and x minus 5, one on top, one on bottom, they cancel. 2x minus 1 and 2x minus 1, they cancel. So this gives us 4x plus 3, x minus 3, all over x plus 5. Okay, great. Now what we want to do is we want to add something on. Now, it's quite tricky because, I mean, this is a fraction that we have, and we want to add on something which is not a fraction. But in order to add it on, it would be ideal if it had the same denominator. And we can sort of force it to have the same denominator by writing that on the bottom and writing that on the top. So I haven't changed the value of that blue bracket because I've timesed it on the top and the bottom, which could essentially cancel out if we wanted them to, but we don't want them to cancel out because we want it to be like this so that we can add them. Okay, so let's add them together then. So what do we get? Well, gosh, it's a tricky question. We have x plus 5 on the bottom. The denominator stays the same because we're adding fractions, and if the denominator is the same, that's great. We can just add the numerators. But what we're going to have to do is we're going to have to multiply out these two brackets and then add them. Just to double check that there isn't a hidden factor somewhere inside. So multiplying out the brackets gives me 4x squared plus 3x minus 12x minus 9. And we're going to add on this one here, which is 29x plus, I don't want to make a mistake, so I'm going to go to the calculator. 29 times 5, 145. We're also going to have minus 4x squared, that's interesting, and we will also have minus 20x. Okay, just about fitted onto the page there. That cancels with that. X terms, we have 3. X terms, we have 3 plus 29 minus 12 minus 20. 0 x's. Okay, great. So the numerical terms is minus 9 and plus 145. Oops. Which is, of course, 136. So it's just 136 over x plus 5. Wow, what a question. Okay, 48 graph transformations, and I've chosen this one because sine graphs, a lot of people find these the hardest type. So it's just basically find A and B. Okay, so what I always say on these types of questions is draw the sine graph on first. So sine goes up to 1 at a maximum, and that's at 90. Then it comes back down to 0 at 180, and then it goes down to minus 1 at 270, and then it goes back up to 0 at 360. Okay, now let's have a look at what the range is of this sine graph. So the sine graph goes from, it goes up to a height of 1 from minus 1. Now that's the range of sine. It goes up to 1 and it goes down to minus 1. This new graph that we have goes to minus 2.5 and it goes up to 3.5. So this has a gap of 2 originally, and the new graph has a gap of 6. So we can see that it's been stretched by a factor of 3. It has a gap of 6. So we can see it's been stretched by a factor of 3 times larger. So therefore the A value is 3 because that's what stretches in the y direction. Okay, so A is 3. Now, in order to find how much it's been shifted up, what we could do is we can look at this, like the center line of the sine graph. So the center line of this original sine graph is along the x-axis, and the center line of the new sine graph is at 0.5. So you can see it's been shifted up by 0.5. So B term is 0.5. Definitely check out my other video from series 1 and series 2 of graph transformations, because there's lots more other ones where you've got to shift, and it's definitely worth checking that out. Okay, question number 17, and we have, horrible looking third question. Anyhow, 8 root m plus, so root 49m is the same as root 49 times root m, which is the same as 7 root m. So that's 7 root m. And again, in a similar fashion, root 9 m is equal to root 9 times root m, which is equal to 3 root m. So that's minus 3 root m. So we've got 8 plus 7 minus 3 is the same as 12. So this is equal to 12 root m. So k is 12. Okay, classic rationalising the denominator here. So the first thing I'm going to do is look at that root 18, because I know that's the same as root 9 times root 2, and because 9 is square, I can write that as just 3, so 3 root 2. So we have 5 minus 3 root 2 over 1 minus root 2, and to rationalise the denominator of a third, we must multiply it by the same numbers on the bottom, but with the sign changed in between them. So this is like multiplying out a double bracket. So I'm going to do 5 times 1, which is 5. I'm going to do 5 times root 2, which is 5 root 2. I'm going to do minus 3 root 2 times 1, so that's minus 3 root 2. And then I'm going to do minus 3 root 2 times by root 2, which is the same as minus 3 root 2 times root 2 is just 2. So times by minus 3 gives me minus 6. And on the bottom, we're going to get a nice little cancellation, but I'll just go through each step anyhow. 1 times 1 is 1. 1 times root 2 is root 2. Minus root 2 times 1 is minus root 2. And minus root 2 times root 2 is minus 2. So this gives me a total on the top of 5 minus 6 is minus 1. And the thirds, we've got 5 root 2 minus 3 root 2, which is plus 2 root 2. And on the bottom, these cancel out nicely. So we're just left with minus 1 minus 2, which is minus 1. Okay, so dividing through by minus 1 is just going to change the sign of the numerator. So the minus 1 becomes a plus 1, and the 2 root 2 becomes a minus 2 root 2. And that is good. Okay, 50, and the diagram shows a cross-sectional, the cross-section of a circular water pipe. Okay, great. We've got sector, we've got a shaded region in the diagram represents the water flowing into the pipe. Okay, the water flows at 14 centimeters per second in the pipe. Work out the volume of water that has flowed through the pipe in 3 minutes. Wow, okay. Well, what we need to work out is that shaded area. That's what we need to do first. So how are we going to do that? Well, we're going to work out the area of the sector. And that is 72 degrees over 360. That's the angle of the circle that we are using, times by pi r squared. Okay, great. So that will be, on our calculators, we could do that. So that's 72 over 360. And we're going to times that by pi. And we're going to times that by 4.8 squared. And we are going to get 14.476. Okay, now we need to work out the area of that triangle. Because we need to subtract that from the area of the sector to get the area of that shaded region. So the area of the triangle, we're going to use a half AB sine C. So that's a half times by 4.8 times 4.8 times by the angle in between the two sides, which is 72. Okay, so that is 0.5 times 4.8 squared, essentially, times by sine of 72. And that gives you 10.95, or 6. Okay, great. So the shaded area is equal to the 14.476 minus the 10.95. So again, I'll do that on the calculator. So 14 point, oops, didn't mean to do that. 14.476 subtract 10.95, or 96, wasn't it? Yeah. And that gives me the area is 3.516. Okay, so that is the shaded area in centimeters squared, and then we need to multiply that by the flow rate. So 3.516 needs to be multiplied by 14 centimeters per second, and that is happening for 3 minutes. So that's 3 times 60 seconds per minute. So multiplying all that together should give us our answer. So times by 14 times by 3 times by 60, and that gives me 8,860 to 3 significant figures centimeters cubed. Just check the mark scheme, and because I rounded, I didn't get the correct answer. It should be this, even though it did say accept anything in the range from 8820 below. So I would have got it correct, but it's not the best answer. This is the best answer. Always remember, keep the exact values in your calculator, unlike what I did. Okay, volumes of cones and spheres. Given that the surface area of a sphere, well, you're given that formula, it's 4 pi r squared to find the surface area of a sphere. And we're saying that that's equal to 49 pi. Get rid of the pi's on both sides. Divide through by 4. Square root, and we get a lovely 7/2. And now it says find the volume of the sphere. Well, again, you're given this formula. It's 4/3 pi r cubed. So this is 4/3 times pi times by 7/2 cubed. Okay, so to the calculator, and we will type in 4/3 times by pi times by 7/2 cubed. And it says the nearest integer, so we need the decimal expansion, which is 179.59. So it's the nearest integer, that is 100 and, whoops, that is 180. Okay, sine and cosine rules. What have we got going on here? We've got angle 64 down there. We have just 2 triangles. It says work out the length of DE. So DE is this one over here. Let's call that X. Okay, so we're going to have to use some information in the left-hand triangle to then transfer it to the right-hand triangle. And I assume we're going to need to find this angle here because that will be the same as that angle there. Okay, now do we have enough information to find out that angle? Well, not quite, but what we do have is we do have a pair of angle and sides that are opposite. So what we're going to actually find is this angle up here, alpha, because that one has a side length opposite it. And then once we found alpha, we can find theta because we know angles in a triangle add up to 180. So let's start. Sine alpha over 24 is equal to sine 64 over 31. Yeah. So sine alpha is equal to sine 64 over 31 times 24. Okay, let's put that in our calculator. Sine 64 over 31 times by 24. And this gives us that sine alpha is equal to 0.695. So we can find alpha by doing sine to the minus 1 of that value. So that's 44.1. So then we can find theta because that is 180 minus the other angles in that triangle, which we have worked out to be 44.1. And we know is 64. So we do 180 minus 64 minus that previous answer, and we get 71.9. Sorry, yeah, 71.9, that's right. Okay, and that is the same as that theta because of opposite angles, vertically opposite angles. Okay, so now we can use the cosine rule to work out x. I know it's the cosine rule because there's only one angle in that triangle and we are trying to work out, well, we have two of the sides and we're trying to work out a third. So it's definitely the cosine rule. So x squared is equal to a squared plus b squared minus 2 lots of a times by b times by cosine of the angle which we worked out was 71.9. And of course you get given the cosine rule and the sine rule, so we don't need to worry too much about remembering them, even though I would recommend committing them to memory. Times by cosine, and I'm going to use the same answer as before. Okay, that's x squared, which is this. So then all we need to do is square root to get our final answer of 20.7. Beautiful, great question that. Love that question. Okay, question 23 is a bit of a beast. So we need to find the angle that AJ makes with the base of the prism. So to do questions like this, what you're going to want to do is draw a line that connects A and J. Draw a line directly downwards from J, and then draw a line to connect up to make a triangle. Excuse me, that would be a right angle, and then this angle in here would be the angle that you're looking for. Okay, so we haven't got much information to go off yet. If I just draw out this front shape like this, then hopefully we can work out what x is. So we have, if I just draw a dotted line like that, we have x and x there to make 2x along the bottom. We've got x here, we've got 8 up here, and we know that this angle here must be 30 because the whole angle is 120. Okay, so this side is also x by symmetry. So we can work out what x is. So this is cosine. So we can say here that cosine of 30 is equal to the adjacent x over the hypotenuse 8. So x is equal to 8 cosine 30, which is equal to 4 root 3. Yes, that's correct. Okay, obviously you use a calculator to do that. I know that because I know my exact values of trigs. Okay, so we've got that in the bag, which is very helpful, because now what we could do is start actually working out side lengths of our blue triangle. Okay, if I just make this a right angle triangle like that, then we know this is 12 along here, and this is 4 root 3 along here. So we should be able to find this value along the base, which I'll just call b. So b squared is going to equal 12 squared plus 4 root 3 squared, which is 144 plus 48. So b is going to equal the square root of 144 plus 48, which is the square root of 192, which is 8 root 3. Okay, great. And then next, we need to work out another side. I'm going to go for this one, the green side, which is the same as this distance here, which is x up to this point, and then this distance in here is going to be, well, we can use sine to find that out, because sine of 30 is the opposite, which is the distance we're looking for, over the hypotenuse 8. So that distance in there is going to be 8 sine 30, which is equal to 4. So we have 4 at the top, and we have x at the bottom, which is 4 root 3. Okay, right, I think we're good to find theta now. Okay, so theta is inverse tan of the opposite, which is 4 plus 4 root 3, over the adjacent, which is b, which is 8 root 3. So that can go directly into our calculator, and hopefully that will give us the correct answer. Let's do 4 plus 4 root 3 over 8 root 3. We get 38.3. Brilliant. Okay, we've got a classic completing the square question. We are going to take out a 5 so that we have x squared inside the bracket, and this will give me 4x, and I'm going to leave the 23 outside, like so. Okay, now we complete the square inside the bracket. So we always look at the x term and we half it. So in this case that's minus 2, and that gets squared like that, and then we always take away that value squared. Again, if you want me to explain this in a bit more detail, check out my video where I go through every single topic. And then if you want to do more exam questions like this, with more application, then check out my series where I go through every topic and I do exam questions on all of them. So, sorry, I've distracted myself there. We do 5 times this, and then we do 5 times this. Now, what is that? That is minus 4, so that gives me minus 20 when I times it by 5. And then all that's left to do is just collect up those terms at the end, which gives me plus 3. And we're done. Okay, 55. This is such a classic Edexcel IGCSE question. These are coming up all the time, so this is great practice. We've got a kite, so I'm going to draw it like this. Notice that it's labelled ABCD, which means that the vertices must go in that order as you go around the shape. It says that B has a negative x and D has a positive x. So I'm going to put B on this side. So it means I'm going to go A, B, C, D. And we know that AB is equal to AD. So these two are the same. And CB is equal to CD. So those two are the same. Okay. A really important thing about kites is that they have diagonals that meet at right angles, which is going to be super helpful for this question. Okay, we know that the straight line L, which connects B and D, is parallel to the equation, the line with this equation. So let's find that gradient by setting it equal to y, so adding the 3x to both sides, and then dividing through by 5. So this gives me the gradient of that line, which is also the same as the gradient of our line which we're looking for, which is 3 over 5. Okay, so BD is y is equal to 3 over 5x plus c. So we know it has the same gradient. So we know the gradient, but we don't know the y-intercept. But we do know a point on the line, 8, 7. So we could sub that in to find the y-intercept. So if y is 7, then x is 8. So this gives me 7 is equal to 24 over 5 plus c. 7 is the same as 35 over 5. Which gives me a C value of 11 over 5. Yes, that's correct. So we know that BD is equal to 3 over 5x plus 11 over 5. Okay, so that's helpful. Now we've got the equation of BD, we can find out a point on BD, which we don't fully know yet, and that's K1, the point B. So we can find out K by subbing in the y coordinate into our equation of a line, and that should give us the corresponding x coordinate. So y is equal to 3/5 x plus 11 over 5. So times through by 5. Subtract the 11 and then divide through by 3. Okay, great, we've got the x coordinate, which now means what we can do is we can find the midpoint of this line, which is going to be very helpful because that is a point which is definitely on AC. Okay, so the midpoint is of course x1 plus x2 over 2 and y1 plus y2 over 2. So the two x values are minus 2 and 8, and the two y values are 1 and 7. So this gives us a midpoint of 3 and 4. Okay, right, we are nearly there. We know AC has a perpendicular gradient to the line BD because the kite diagonals meet at right angles. So the perpendicular gradient is the negative reciprocal So I flip over the gradient and I change it from a positive to a negative, or negative to positive, if it was that the case. So that's the equation of AC. And I've got a point on AC that I can sub in to find the C value. So 4 is the Y, and 3 is the X. So 4 is equal to -5 plus C. So 9 is equal to C. So Y is equal to -5 over 3x plus 9. And the last thing to do is put it in the form they want it in. So we're going to times everything through by 3 to make all the numbers integers. And then we're going to bring all the x and the y variables over to the same side and leave the constant over there. And that is job done. '56 functions. We've got a function which is given as this. Express the inverse function. Okay, so to find the inverse function, we do y is equal to k of x. We swap over the x and the y because we're changing the input to the output and the output to the input. And then we rearrange to make y the subject. So times both sides through by y and then divide through by x. And that is fantastic because reciprocal functions actually are the inverse of themselves. Okay, next one. The function g is such that we have 2 minus 3x to the 4. And the h function is given as this. Find g of minus 2. Okay, that means I just need to sub in minus 2 into g. So 3 lots of minus 2 to the 4. Which is 2 minus 3 lots of 16. So that's 2 minus 48, so that's minus 46. And it says express the composite function hg. So that means I'm putting g into h. So what I'll do is I will write I'll write out h, but I'll replace every x with the whole of the function g. So it's 3 over, not x anymore, but g of x. And that's over 2 minus, again, not x anymore, but g of x, like such. Okay, once in its simplest form, so let's expand out the brackets on top, which is going to give me this. And let's expand the brackets on the bottom. So I'm going to get 2 minus 2, which is 0. And the negative is going to apply to the negative 3. So that's going to become positive 3. And I think that is the... Oh no, not quite the simplest form. We can divide everything through by 3. So it's 2 minus 3x to the 4 all over x to the 4. And that is the simplest form. Job done. 57, differentiation. We have the radius of a right circular cylinder is x. The height of the cylinder is given as 800 over pi x minus x. Okay. I don't know where this is going. The volume of the cylinder is V. Okay. Find the maximum volume of V. Okay, so therefore V is equal to, well, the volume is of a cylinder is the base area, which is pi times r squared, r being the radius, and in this case x, times by the height, which in this case is 800 over pi x minus x. Okay, so multiplying through pi x squared times by 800 over pi x. Well, the pi's are going to cancel, and there's going to be x squared divided by x, which is just going to be x. So the first term is going to give me 800x. Again, because we're going to get pi x squared times by 800 over pi x, and we're going to get pi's to cancelling, and x squared is going to cancel with x to just leave an x on top. And then the other term will be just pi x cubed. Okay, now to maximise, we need to differentiate. So dv by dx is going to be 800, because 800x differentiates to 800, and this will differentiate to 3 pi x squared. Now if you're not sure how to differentiate, check out my video where I go through every single topic, explain it in detail, and obviously figure out how to differentiate. But for now, I'm just going to try and solve the question to try and keep the video under a decent amount of time. Okay, so I want to set this equal to 0 because maximums and minimums happen when the derivative is equal to 0. And we can solve this by minusing or plussing over the 3 pi x squared, and then dividing through by 3 pi, and then square rooting. So x is equal to the square root of 800 over 3 pi. Okay, now x needs to be positive, so when I square root there, I'm not going to get plus or minus. X has to be positive because it's a distance, a length. Okay, so that is going to be our maximum, and we need to find the actual value of v. So the maximum occurs when the x value is that, so we need to sub that back into v. So remember, v was this equation over here. So I'm going to, which then got simplified to this, so that's much nicer. Let's use that one. So it's going to be 800 times by x, which is root 800 over 3 pi, minus pi times by, again, root 800 over 3 pi cubed. Okay, so on my calculator, I'm going to just type in 800 over 3 pi rooted, and I'm going to press equals. That's going to be in my calculator as the answer button. So I do 800 times by the answer minus pi times by the answer cubed. And that gives me 4,913.7. So to the nearest number, integer, whole number, is this. And that will be centimeters cubed. Voila. Okay, next topic, kinematics, which is a form of differentiation, and we differentiate between displacement, velocity, and acceleration. And we differentiate down. So to find the expression for the velocity, we have to differentiate the displacement with respect to time. So the 3 comes down, times by the 2 to make 6, and then drop the power down to a 2. 2 times 12 is 24, drop the power down to 1, and 1 times 7 is 7, drop the power down to 0, so the t disappears. Again, check out my video where I go through all the topics if you need more details. Okay, so that is the velocity, because the velocity is the derivative of the displacement. So that is 6t squared minus 24t plus 7. Find the time at which the acceleration of the particle is instantaneously 0. Okay, so to find the acceleration, I differentiate the velocity. That's going to give me 12t minus 24. Now I love this topic. It's always at the end of the paper, and it's not as difficult as you might think, as long as you can differentiate, you should be able to get a good amount of marks on these types of questions. We want to know when it's equal to 0. It's when it's instantaneously 0. So we set it equal to 0, plus the 24 over, divide by 12, t equals 2. There you go. 4 marks in like 40 seconds. It's a good topic if you know how to do it. Okay, 59, sequences. And this one is a real tricky one. But as long as you follow it step by step, we can get to the answer. First thing, first term is 2t plus 1. So I write a, which is what we define as the first term, is equal to 2t plus 1. Okay, I've used that bit of information, great. Next bit of information, the nth term of the series is 14t minus 5. Well, the nth term formula is a plus n minus 1d. Now that's one you have to remember, you're not given that. And we're told that's equal to 14t minus 5. Okay, well, I know what a is. It's 2t plus 1 plus n minus 1. And I know what d is. That's the next bit of information. So I can write times by 3. Okay, so now I can simplify this a bit. I can minus 2t from both sides, and I can minus 1 from both sides, and I can expand these brackets to get 3n minus 3. And I can add 3 to both sides, which gives this. Yep. And then I can divide 3 by 3, and I get this. Okay, that's as far as I can go with the information that we've used so far. I can't go any further, so we need more information. Now these questions, they give you all the information. There's no red herrings. You have to use everything they give you. Okay, so the sum of the first n terms. Well, we know that sequence, that formula is given in our formula book, and it's n over 2, 2a plus n minus 1 d. Okay, well, I know a lot of this already. I know n is 4t minus 1, so over 2. 2 lots of a is 2 lots of this, so that's 4t plus 2, so I'm doubling a. N minus 1, well I know what n is 4t minus 1, so n minus 1 will be 4t minus 2. And that's times by d, which is 3. Okay, I know that it's got to be this form, but I'm just going to try and simplify it first before I deal with that. So this is like a half times 4t minus 1. Just rearranging that bit at the front. And then this big square bracket is the same as, what am I going to get? I'm going to get 4t plus 2 plus 12t minus 6. So that is 16t minus 4. Okay, right, I'm looking at this, what they want it in, and it's qt minus 1 to the power of r. So I'd almost want to have 2 lots of this 4t minus 1. That would be really helpful. So what I could do is I could write this one here could be factorized. I could take out a 4, and that would be 4t minus 1. Oh, that's brilliant. That is absolutely lovely. We have a half times by 4, which is just 2. and we have we have this 4t minus 1 times by itself. So that's squared. And that's it. That is the perfect form. That is the form they are after. So therefore we can say that P is the 2 outside the bracket. Q is the 4 next to the T inside the bracket. And R is the 2, which is the power. Fantastic question. Love that. Number 60, we made it all the way to the end. Let's finish this off in style with one of these beastly vector questions. But with that being said, they are very repetitive if you've done enough of them. Okay, we've got all this information here, and we know that OCE is on a straight line, and we want to work out the ratio of O to C to C to E. Okay, so what we're going to do is we're going to look at these two crosses, these two lines that cross, the blue line and the orange line, because those are the ones that cross at C. And we're going to find an expression for O to C going down the blue line and going down the orange line. Okay, but before we can do all of that, we need to find as much information as possible. So let's start with A to B. So A to B is minus 2A plus 2B, because we're going this way and then that way. So minus 2A plus 2B, which I could write as 2B minus 2A, just a bit neater. Okay, now I can work out B to D, because I know that A to B and B to D is a ratio of 1 to 2, so B to D is just twice AB, which is 4B minus 4A. That means I can also work out A all the way through to D, because that will be the two of them added together, which would be 6B minus 6A. Okay, and now what I could do is I can work out O to E. That could be quite useful. O to E, I could go this way, that way, and then that way. So that is going to be 2B plus BD, which is 4B minus 4A, plus DE, which is 7A plus 3B. So that gives me a total of 9B plus 3A. Okay, so what I'm doing now is I'm just trying to get as many vectors down as possible, basically, just in case I mess up and the examiner can give me a couple of marks at least. But also, I now have the blue line and the orange line. In fact, let me give this a different colour. Beautiful. Okay, great. I've got the green line and I've got the orange line, which is what I was hoping for, because these are the two lines that cross at the point C, which is what we're essentially what we're trying to find. So what I can do now is I can say that A to C on the orange line is some fraction of A to D. I don't know how much that fraction is, but it is on the same line AC as AD, so it must be some fraction of the way along. And again, what I could do is I could say that in terms of the green line, O to C is some fraction of the green line. So it's a different fraction. I'm going to call it mu. But it is a fraction of the green line, which is 9b plus 3a. Okay, right, this is handy because what I can do now is I can find O to C in two different ways. And this is the essence of how we do these questions. So I can get two expressions for O to C. The first one, I will use the green line, and in fact, we've already found it. It's mu lots of the green line. The orange line, I'm just going to have to take a little detour, and that is going to go to A, and then I'm going to go across to C. So that's 2A plus AC, which is lambda 6B minus 6A. Okay, I can write this out now as 9 mu B plus 3 mu A. And this one I could write as, well, 2A plus 6 lambda B minus 6 lambda A. And I can collect up the A's. I can factorize an A here. And by doing so, I will get 2 minus 6 lambda A and then plus 6 lambda B. Okay, well, why am I doing this? Well, OC is the same. OC is OC. And it's the same, so these two things must be equal. And we can compare coefficients. So the amount travelled in the A direction must be the same on both sides. So that tells me that 3 mu must equal 2 minus 6 lambda. And by the same token, the amount travelled along the B direction must be the same on both sides. So 9 mu must equal 6 lambda. 9 mu equals 6 lambda. Okay, so what we could do is we can add these two equations together and solve them simultaneously, because I've spotted that we've got a minus 6 lambda there and a plus 6 lambda. So that gives me 12 mu equals 2. So mu is equal to 2 over 12, which is 1/6. Okay, let's sub back in and find lambda, because lambda is... Oh no, mu's good. Mu's exactly what I need. Mu is exactly what I need because that is going to tell me exactly what OC is. And in fact, mu is what we defined as the fraction of OC along the green line. So if I draw out OC a bit clearer, we've got O here, we've got E at the end, sorry, and we've got C here. And this is 1/6 of the fraction of the line OE. So therefore this part is 5/6. So therefore the ratio is 1 to 5. And that is my final answer. And with that, I hope you enjoyed this predictive paper covering all topics. But with that being said, it has covered all the topics, but it hasn't covered every topic in exact detail because it's only been one question per topic. So to be fully clued up, check out my other videos, the whole IGCSE examples, and also my series where I go through every topic and I do exam questions, multiple exam questions on each topic. And I have 2 series like that. Check them out. Good luck in your final exam. If you have found this useful, please do like, share and subscribe. Bye for now.